Hello dear students, in this session let us move to the next topic in your cryptography, that is classical encryption techniques. So first let us discuss the symmetric cipher model of your classical encryption technique. Okay, first let us discuss symmetric cipher model. So now I will write the block diagram for this in order to discuss the symmetric cipher model. Just observe on this carefully. This is nothing but your plain text. Plain text will subjected to encryption. So I will denote that plain text as just X. This is nothing but encryption algorithm. Which is known to both sender and receiver. Okay, so now how the encryption algorithm works. Inside this we have some secret key K, and this secret key shared between sender and receiver, right? So here it will be transmission. I will say that as transmitted cipher text, and using notation I can denote that as Y is equal to E of K comma X. Y is nothing but your cipher text. You are producing your cipher text by using encryption algorithm. In that we will be having secret key and plain text, right? So this is how I will represent the transmitted cipher text. Similarly, again to the receiver side there will be a secret key. The same key here you will be having. So this process is nothing but decryption algorithm. That means the transmitted cipher text, again it should convert back to the plain text. For that we will use the decryption algorithm, which is I can say that this is a reverse process of encryption algorithm, right? Again this key K is a secret key which is shared between sender and receiver. Right? So here the transmitted text will be, you will be getting X. So X is equal to D of K comma Y. That means you are getting a plain text using decryption algorithm with the help of secret key K and a cipher text Y. So finally again you will be getting a plain text, right? This is the procedure, or this is the process you have to follow in your symmetric cipher model. Okay, so here the main terminologies we are having is plain text. Plain text is nothing but it is a original readable message, right? Readable message, or we can say that data, or I can say that data which is fed into algorithm as input. That means we are talking about this plain text. Okay, so the next important terminology we are having is encryption algorithm. We have already discussed this. Encryption algorithm is nothing but it is an algorithm which performs various substitution and transformations on the plain text. So this is a algorithm which performs various substitution and transformations on the plain text, right? So similarly, the next important terminology is nothing but secret key. So how you define your secret key? Secret key is also input to the encryption algorithm. Secret key, this is also an input to the encryption algorithm, and the algorithm will produce different output depending on this specific secret key, right? The next thing is we are having ciphertext. Ciphertext is nothing but converted message produced as output from the encryption algorithm. So here using secret key you got some output which is a converted form of your plain text. That is your output, right? Which is nothing but ciphertext. And the last one is decryption algorithm. Decryption algorithm or nothing but this is also a type of algorithm which is a reverse process of your encryption algorithm, and you can say that it takes the ciphertext and key to produce the original readable text or original plain text. So we have seen the symmetric cipher model and the process involves in your symmetric cipher model, and we discussed some of the important terminologies in this process, right? So next we will move to next topic, that is model of symmetric crypto system. Model of symmetric crypto system. You will be having a block diagram even in this topic. First I will write the block diagram and we will discuss one by one in that block diagram. Okay, let us fill the blocks now. This is nothing but message source. From message source, or I can say that message source as a plain text, say X, it is subjected to encryption algorithm. So if we have encryption algorithm means I should have key source also. This is nothing but key source. Okay, so here obviously it will be a decryption algorithm. This is secure channel, and this is the destination. Since I have message source X, I will be having destination which is nothing but your plain text again. So I can represent this transmission as y is equal to e of k comma x. Here it will be x itself. So this block is nothing but cryptanalyst. So here there will be estimated plain text, as I will denote that as x cap, and estimated key source I will represent that as k cap. This is how using block diagram we will explain the model of symmetric crypto system. Okay, how the process goes on is, first in the source a message will be produced, that is a source produces a message, and that will be in, as we know, plain text, right? I will denote that plain text as x, x1, x2, so on up to xn. This is nothing but my plain text. Okay, since we are generalizing the concept, I am using in this form, that's it, don't get confused. Next I will be having a key source. So a key source, say k, will be in the form of k1, k2, so on up to kj. This will be generated. Okay, if the key is generated at the message source, then it must also be provided to the destination. So as we have seen here, in order to encryption we need a key, and also after encryption you will be getting a ciphertext. In order to convert this ciphertext into plain text back, again you need the key. So what we are doing here is, key source is common to both encryption and decryption. So using secure channel we are connecting the both. Okay, now we will be having a ciphertext. Ciphertext I can denote as y. So this will be generalized one, so y1, y2, so on up to ym. This will be produced, right? This ciphertext will be produced using encryption algorithm. So the message x, and that is nothing but using the message x and key source k. So I can denote my encryption algorithm as y is equal to e of k comma x. This notation indicates that y is produced by using encryption algorithm e as a function of the plain text x, and it is determined by the value of k. This is how we read. Okay, so now the receiver with the key is able to invert the transformation. That means that decryption algorithm takes place. Decryption algorithm is nothing but reverse process of your encryption algorithm, right? So I can denote that as x is equal to d of k comma y. Now an opponent observing y but not having k or x. There is a third party. Here he is observing your ciphertext, but he don't know about secret key k as well as plain text x. So this third party may attempt to recover x or k, or he can recover both. Okay, so what I am trying to explain you is, this third party is observing your ciphertext y and he is not knowing anything about k or x. So what he may do is, he may attempt to recover your plain text or your secret key, or he can attempt to recover both, right? So now it is assumed that the opponent knows the encryption and decryption algorithms. As we have seen in the modern and classical cryptography techniques, sometimes what in the modern cryptography what happens, your encryption and decryption algorithm is public knowledge, right? So if that is the case in your symmetric crypto system, what happens is, the third party knows encryption and decryption algorithm, and he is observing your ciphertext, but he is not known anything about your plain text as well as your secret key. So he is trying to attempt to recover either X or K or both. Okay. So what he may do, the opponent may do one of the two things. One is he is recover X by generating a plain text, and we will call this plain text as estimate X cap. If the opponent is interested in only this particular message, right? So if he is only particular about the message, then he will recover X by generating a plain text, that is X cap. Here I have represented X cap, you can observe. So similarly he can do one more thing. If we want to know the future messages also, what he must do, he has to recover K by generating an estimate K cap, right? So if he just knows, if he just want to know the present conversation, then he will recover X by generating a plain text and estimate X cap. But if he wants to know the future conversation also, future messages also, then he must find the secret key. So for that what he will do, he will recover K by generating an estimate K cap. This is what your estimated K cap. Okay, using this process the opponent may know the encryption and decryption technique, and he might find the plain text which need to be maintain secrecy. Okay, so this is about model of symmetric crypto system. Now let's discuss some of the types of attacks on encrypted message. Okay, on encrypted message, that is after your plain text subjected to encryption algorithm, you will get a ciphertext, right? On that ciphertext there are some attacks takes place. Let us discuss some of the types on your encrypted message. Okay, first one is ciphertext only attack. In short, we can write that as COA, ciphertext only attack. Okay, in this attack what happens is the attackers have to access to a set of ciphertext, but he does not have corresponding plain text. So he will be having a set of ciphertext, but he does not access to the corresponding plain text. Then ciphertext only attack is said to be successful if the plain text can be determined from this ciphertext. This is what we called as ciphertext only attack. Similarly, we have the next one as known plain text attack. In short, I can write this as KPA, known plain text attack. For this, if I have a plain text, say what are you doing? This is my plain text. Okay, what happens in known plain text attack is some part of the plain text, or we can say that some part of the ciphertext for some part of the let us consider this is the ciphertext for this plain text. Okay, for some part of this, that means I can consider SUB and UAB. Attacker knows the plain text for some part of the ciphertext. His task is to decrypt the rest of the ciphertext using this information. It's like in a sentence for 2 or 3 words, To the attacker, already he knows the plain text. He has to decrypt the rest of the ciphertext using this information. That means using this information he can predict the value of k, and using that he can decrypt the remaining part of the ciphertext. This is called as known plain text attack. Okay. The next one is chosen plain text attack. We can represent it that as CPA. In this method, to the attacker, okay, some part of the plain text, some part of so for attacker already has some part of the plain text. So what he will do is he has the ciphertext plain text pair. Ciphertext plain text pair of his choice. So he just want to find the rest of the plain text using encryption key. That is nothing but chosen plain text attack. Don't get confused with known plain text attack and chosen plain text attack. In known plain text attack, attacker knows the plain text for some part of your ciphertext. So for this ciphertext, he will be knowing some part of your some part of the plain text for the ciphertext. But in chosen plain text attack, attacker has the some part of plain text. So he has the ciphertext plain text pair. Then he can determine rest of plain text using the encryption algorithm. Okay. The next one is dictionary attack. I can represent that as DA. In this dictionary attack, the attacker builds a dictionary of ciphertext and corresponding plain text. This is not done in 1 or 2 days. He will maintain this over a long period of time. Okay. So once he get the ciphertext, what he will do is he will check in his dictionary. Okay. It's like check in future. When an attacker gets the ciphertext, he refers the dictionary to find the corresponding plain text. For example, you can observe here only. He might have the set of plain text and ciphertext and corresponding plain text in his dictionary over a long period of time. He will check for this. He may get this in his dictionary. He may get this for this in his dictionary, or he may not. It depends, right? So what he will do is, once he will get the ciphertext, he will check in his dictionary for the corresponding plain text. This type of attack is nothing but dictionary attack. And the last one is brute force attack. This is nothing but BFA. In this method, the attacker tries to determine the key by attempting all possibilities. Like if the key is 8-bit long, let us consider we have a key and it is 8-bit long. So for this, the number of possibilities is 2 power 8, which is nothing but 256, right? He will try to determine the key by attempting all 256 possibilities. The attacker knows the ciphertext and the algorithm. Now he attempts for all the 256 keys one by one for decryption. But what happens is the time consumption of time will be more in this type of attack. But this is how brute force attack happens. Actually, this type of attacks happens in your ATM card. For example, you can give us ATM card. because in our ATM card the card pin will be of 4-bit long, right? 4-bit long means the possibilities may be very little high, but the attacker can try for one or the other. He will be having encryption algorithm, he will be having ciphertext. So since he know that there are only 256 possibilities, he can do trial and error method in order to find the plain text. This is nothing but brute force attack. So we have seen 5 types of attacks on your encrypted message. One is ciphertext only attack, second one is known plain text attack, third one is chosen plain text attack, fourth one is dictionary attack, and fifth one is brute force attack. So in the next session I will start with the introduction to a number theory. Okay, thank you.